This is Module 2. We're now dealing with congruence transformations. And congruence means that we're dealing with figures that are exactly alike. Okay? Congruent means exactly alike. Corresponding sides are congruent, corresponding angles are congruent. Like these triangles here, essentially if I'd drawn them well, both of them have a 90-degree angle here. Both of them have a 30-degree angle there. Both of them have a 60-degree angle here. Same size, same shape. This side would be the same length as this one. This side would be the same as that one. This side would be the same length as this one. That's what's meant when we're talking about congruent figures. Two figures that I can map on top of each other and prove that they are the same. Now, the type of transformations that can create congruent figures are reflections, translations, and rotations. And we're going to talk about each one of them and give some examples. And I'm going to use these little picture corners to show you what I'm talking about. Congruence transformations can create congruent figures. If I start with this figure, and I want another one of them, and I say copy and just move it over here, I have created two congruent figures. They're exactly alike. Their angles are the same. See, this angle and this angle looks the same. This angle and that angle looks the same. This angle here and that angle looks the same. All these corresponding angles are the same. How about the side lengths? That one is the same as this. This one is the same as that, and so forth and so on. I can take this figure, move it over here, put it on top of this one, and they would be exactly the same figure. In fact, that is how we prove that two figures are congruent, is we describe a series of transformations that can move one on top of the other and prove they're exactly the same. Now let's talk about each of the types of transformations, congruence transformations. Let's start with a reflection. A reflection is when you start with a figure and you flip it over. If you are on a computer program and you're making some sort of design, you might want to flip this over. This one's been flipped vertically, okay, or horizontally. This one's being flipped over. No, it's being flipped vertically. All right, it's been flipped over. And what we have created here is a figure that's just like this one. How can I prove that they're exactly the same? Flip it back over onto itself, and you would see that they're exactly the same size and same shape. This line that you're flipping it over is called the line of reflection. Okay? A reflection creates a figure that is congruent to its pre-image. Now, this is some terms that we're going to need, pre-image and image. The term pre-image. Pre-image means what you're starting with. If I'm starting with this one, that would be my pre-image. If I flip it over, what I create is my image. I-M-A-G-E, image. So this would be my pre-image. It's what I started with. And this would be my image. Okay? It's what I started with. This is what I created. A pre-image and an image are going to be exactly the same size and shape if you have a congruence transformation, like a reflection. Pre means before. It's the one you start with. And this is called your line of reflection. Now, here's an example of that, guys. Whenever you see something reflected in a lake, what you get is the pre-image. This is the one that's above ground. And then where it's reflected, you get the image. This is what's created from this one. Think about it. Every point on this tree is going to be exactly the same distance from here, from where it starts to branch. That's the same distance from the line of reflection as it is here. Okay? The top of the tree is going to be the same distance to the line of the reflection as this, the top of the tree and the reflection. This is called our line of reflection. It's what this is reflected over. Okay, this is a reflection. It creates a congruence transformation. It is a congruence transformation that creates congruent images. This is your pre-image, where you start. This is your image, what you get afterwards. Let's talk about another congruence transformation, a rotation. And guys, these things are oftentimes used in creating logos. You're going to recognize some of the Google stuff here. They've used basically congruence transformations, in this case a rotation. Think of this. What if I start with this red figure, as in this would be my pre-image. Pre means before. Okay, and what if we create all these other images from it? Okay, for some reason that graph didn't mean to. It creates all of these images from it. What if we start with this red one? And I use this as my center of rotation. It's like a pinwheel. It's what I'm going to rotate this around. What I'm looking for is the direction I'm rotating it and the degrees of rotation. Well, let's think about a circle. If I go all the way around a coordinate grid, I have gone 360 degrees. If I go halfway around, that's half of 360. Which is 180. So if I go halfway around, it's 180 degrees. What if I just start here and I go to there? That's a quarter of the way around. 360 degrees divided by 4 would give me 90 degrees. Okay, so if I start here on this red image and I rotate it around this center of rotation and bring this, oops, it's not drawing very well. Bring this here, bring this whole image, such that I do that, take the whole image and move it around. I have rotated this 90 degrees. Which way did I go? I went counterclockwise, opposite of the direction that a clock would go, counterclockwise. Okay, or you could say that I rotated it left, either one would do. 90 degrees to create this new image. Then I just colored it different. It's the same size and same shape. The angles are the same. The side lengths are the same. All I did was rotate it 90 degrees counterclockwise or left around this center of rotation. How did I create the green one from this red image? I've rotated this one, what? 180 degrees around this center of rotation to form this image from this pre-image. How about the blue one? Well, I could say that I rotated it 270 degrees. That would be 3 turns, right? 90, 180, 270. I've rotated this 270 degrees to get there around this center, going left, or I could rotate this 90 degrees right, clockwise, right? Get the same image. These images are congruent to each other. They're created from rotations. That means they're congruence transformations. How about this image up here, another Google image? Take this red image here, take this red pre-image, rotate it around, this center right here, rotate it around, and I get this one, and I can color it green. What if I take this and rotate it around this center to here? I get the same image. These are congruent images. I can color it yellow, right? The color doesn't matter. Congruent doesn't have anything to do with color. It only means size and shape, okay? Here's my little thing with my little picture frame edges. In this one, what I've done is, here's my center of rotation. I've rotated this 180 degrees right around this red center of rotation to create the image, from this pre-image to this image. These two would be congruent. They're created by rotation. I could have also called this going 180 degrees left around the center and gotten to the same place. When you're talking about rotations, we will describe them using their center of rotation and the direction and degree of rotation, but they can create congruent figures. You start with a pre-image and you get a congruent image, okay? Now let's talk about the third type congruence transformation. It's called a translation. Translation. Let's say we start with this image right here. And we're going to move it. What if we move it one space over? If I go one space right, I'm going to create this image. That's called a translation. This image is congruent to this one. All I've done is move it over. Same here. If I go up, I've translated this image to here, and created I've translated this pre-image to here to create this image. Or I can start with this pre-image and go up one and right one to create this image, right? Start with the pre-image, go up one and right one to create the image. These would be congruent to each other. Translations simply move things over. It can move them down and over, it can move them just over, it can move them up and over, up and back. The key is to explain where they're being moved. And usually we do it on a coordinate grid, and you'll tell me how many squares they're moving. This is called a vector. It tells you where each point moves. If you start at this point, you can put the vector on top of it, and it should move there. I can take this vector and move it to any point. If I moved it up here, if I moved this to here, it would show me that its end would move this right there. Okay, you can do that for every point. Vectors are frequently used in translations and describing translations. We will not do that in this course except for a few places in the workbook because the state does not test it using vectors. The state tests translations using descriptions of those movements. So we're not going to get too involved with vectors. Now that covers the types of congruence transformations that we have. Remember, congruence transformations move a figure. They can move them by three different types of congruence transformations. A translation, which simply slides something over. A reflection, which flips something over. Or a rotation, which turns something around. All of those you would use if you were using any sort of computer graphics programs, things like PowerPoint, anything like that, when you were moving figures around.